All right, so this is the third and final video of section 4.3. So if you would go all the way down to where we're going to talk about some properties of logarithms. Properties of logarithms. So a couple things here. Notice that we have some restrictions at the top. X and Y and A, all three have to be positive numbers. A is not allowed to equal 1. A is going to be my base. And for any real number R, the following properties are going to hold true. So first of all, we're going to talk about the product property. The product property says, if I have the log of a product, this is going to equal the sum of two logs. Okay, a description of that would say the log of the product of two numbers is equal to the sum of the logarithms of the numbers. An even faster way to say that, a shortcut, the log of a product is the sum of two logs. The log of a product is the sum of two logs. All right, the quotient property. The quotient property is very similar. If I have the log of a quotient, this is going to equal the difference of two logs. So let's go over to the description. The log of a quotient of two numbers is going to equal the difference between the two logs of the numbers. The log of the quotient is the difference of two logs. All right, the power property. The power property says if you take the log of some number x raised to a power, the log of a number x raised to the power, that power can be taken out to the front and multiplied. So notice here we have an r, my power, times my log base a of x. So the description of this, the log of a number raised to a power is going to be equal to the exponent multiplied by the log. All right, the log of 1 is always going to be 0. Okay, think about why that's true real quick. If you change this log into an exponential, it looks like a raised to the 0 power equals 1. Okay, so the log of 1 is always going to equal 0. And then last but not least, the log base a of a will equal 1. Again, think about why that's true. A raised to the first equals a. So the base a log of a is going to equal 1. The catch on this one, folks, is that these two bases have to match. They have to have like bases. All right, so let's use these properties. My suggestion, I can't keep going back and forth between screens, but my suggestion is that you should have these properties in front of you as we go through the next few examples. So let's read the directions first. Use the properties to rewrite. Assume all variables represent positive real numbers where a and b are not allowed to equal 1. One of the words that I like to use in the instructions on these kinds of questions is that you're going to be expanding your logarithm. Okay, so right now, notice that all four of these examples have a single logarithm. We're going to expand it into multiple logarithms. Well, notice for this first one, we have the log of a product. 8 times 6 is my product. So we're going to use the product rule on this. So the product rule says the log of a product will be the sum of two logs. So we're going to take log base 7 of 8 and add to that log base 7 of 6. Once again, I drew the dashed line there simply so that you could see that the base 7 is written lower than the rest of it is. All right, let's slide over to letter B. This one is the log of a quotient. So we'll use the quotient rule. The quotient rule says the log of a quotient is the difference of two logs. So we'll have a log minus a log. Log base 6 of 12 minus log base 6 of 5. Or another way that you could think of that is the log of the top minus the log of the bottom. All right, let's slide over to part C. Remember the rule from section 4.2 where roots can be rewritten with fraction powers. So I'm not going to do anything with the log right now. All I'm going to do is take the cubed root of 9 and rewrite it so that it is a fraction power according to the property in section 4.2 that we covered. So this is going to be log base 2 of 9 raised to the 1/3 power. Well, now I can use my power rule, and I'm going to take my 1/3, and it's going to go out to the front by multiplication. So that'll be 1/3 times the log base 2 of 9. Part D, we'll use the same rule, the root rule. So the first thing that I'm going to do, I'm not going to deal with the log. The first thing I'm going to do is rewrite my root as a fraction power. So this is going to be log base A of r raised to the 3/5 power. And remember, the root is the bottom number. The power is the top number. Well, now I can use my power rule again, and I can take my 3/5 out to the front by multiplication. So that'll be 3/5 times log base A of r. All right, example E. We're getting a little bit more challenging here. Okay, so before I uncover what I have, let me see if I can shift this down just a tad to show my whole original question. Notice that the overall operation is a quotient. So the first thing we're going to use is the quotient rule. And remember, the quotient rule says the log of the top minus the log of the bottom. So that's the first thing I'm going to write is the log of the top minus the log of the bottom. And then what I'm going to do in this piece here, this is going to be the log of a product, only it's 3 pieces of a product. So I'll have a log plus a log plus a log. Over on the other side, I also have the log of a product. So this piece is also going to be the log of something plus the log of something. Okay, so let me go ahead and unhide that then. So notice that the first set of parentheses is my 3 logs added together, and my second set of parentheses is the 2 logs added together. All right, now when I look at some of these, I can't do anything else. Like this one, I don't have any products, I don't have any quotients, I don't have any powers, so there's nothing left. Same with this one. Nothing left. No products, no powers, no quotients. But on this one, and on this one, and on this one, all 3 of these have a power. So let's use the power rule on these three pieces. And there's one more thing I'm going to do. I'm going to take this minus here, and I'm going to distribute to the 2 pieces inside the quantity. All right, so I will unhide all of that at the same time. So once again, you see that the first piece didn't change. The first term didn't change. The second term, we're using the power rule. Third term did not change. The next term, I used the power rule and it became negative because I distributed my negative. And the last term, same 2 things. I distributed my negative and I used the power rule. Now at this point, every single term, there's nothing left. There's no powers. There's no quotients. There's no products that are left. That's how I know I'm finished and I don't have to keep on expanding. There's nothing left to expand. All right, let's go over to F. Now this one, make sure you leave yourself enough space because this one has a lot of steps to it. The first thing that we're going to do is we're not even going to mess with the log. The first thing that we're going to do is rewrite our roots as fraction powers. So leave the log alone, just copy it down, but that mth root is going to be rewritten as a 1 over m power. So now when I look at what I'm taking the log of, the overall operation is the power. So that's the first thing I'm going to take care of is the power rule. And I'm going to do that by taking my power out to the front. All right, so that's going to look like the following. Okay, so now I have my power out front. And now when I look at what I'm taking the log of, the overall operation is a quotient. So the log of a quotient, let's use the quotient rule, is going to be log of the top minus log of the bottom. Now, one of the things that you'll notice here is that in the last step, 1 over m is being multiplied by the whole entire log. So when I take this log that is currently in a box and I split it into 2 logs, that 1 over m needs to be multiplied by the whole entire thing. At the end, I'm going to distribute the 1 over m, but for now, you just need to understand that 1 over m is being multiplied by the entire thing, which is why I used a set of brackets. You could also use a set of parentheses. Okay, so now I have 2 separate logs, but are they fully expanded? When I look at this log is the log of the overall operation, a product. So I'm going to use the product rule here. But on this one's not the log of a product. This one is using a power. So on the first set, I'm going to use the product rule. And on this one over here, I'm going to use the power rule. Product rule and power rule. 1 over m is still being multiplied by the entire thing. All right, so you'll see here that the log of a product is going to be the log of the first piece plus the log of the second piece. And I apologize, I lied to you. I did not take care of the power rule. Apparently, I'm going to do that in the next step. So I only took care of the product rule here. All right, so then the next thing is you ask yourself, hey, do I have any more products, any more powers, any more quotients that I need to take care of? And this term has a power, this term has a power, and this term has a power. So all 3 of these, we're going to use our power rule and take it to the front of each of those logs. Take the power to the front of each log. So you'll notice the 3 went to the front of the log, the 2 went to the front of the log, and last but not least, the 4 went to the front of the log. The only other thing I'm going to do, and at this point, you notice I have 3 logs, but there's no powers, products, or quotients left in any of those 3 logs. So the last thing I'm going to do is I'm going to take my 1 over m, and I'm going to distribute to the 3 terms. And so this is going to become 1 over m's. I apologize. There's a mistake there. This should be 3 over m times the log base a of r plus 2 over m log base a of s minus 4 over m log base a of t. All right, so that's how we expand logarithms. Well, for the next one, notice for this example 6 here, it says that we should write each expression as a single log. Now look at our 3 examples. Here's 3 separate logs, here's 2 separate logs, and here's 3 separate logs. And we're supposed to condense them, and that's the word I like to use here. On this section, I like to use the word expand. On this section, I like to use the word condense. And so we want to condense these logarithms into a single logarithm. All right, so here we go. Notice that for part A, let's only look at the first 2 pieces. A log minus a log looks like the quotient rule. And so the difference of 2 logs can be rewritten as the single log of a quotient. So you'll notice here my 2 logs were condensed into a single log of a quotient. The last term was just copied. But now what you notice is that I now have a log plus a log. Well, when I add together 2 logs, this is the product rule. And so this is going to be the log of a product. A single log of x over y times z. Now, I did do what I was asked. I was asked to write as a single logarithm, but there is a little bit more cleanup that I can do here. I am able to multiply my two fractions together, so that's the last thing I'm going to do. Multiply the tops and multiply the bottoms. So we have log base 4 of xz over y. All right, let's look at letter B. Okay. So now when I look at my logs, please don't see this as a log minus a log because it isn't. My 4 and this 5 are messing with things. So the first thing that we're going to do is we're going to work the power rule. So let's take this power and put it back where it belongs. And this 5 as a power, let's put it back where it belongs. So that's the first thing that we're going to do here. Now you can say you have a log minus a log. So now I can use the quotient rule. So this is going to be a single log of the first guy on top over the second guy on bottom. And there's nothing else I can do to clean that up. That's as clean as it's going to get. All right, let's go to part C. This one is a little lengthy. I had to use 2 columns on this one. Once again, let's take this and replace it as a power. This as well, replace it as a power. So that'll be the very first thing that I do. So notice my 1/3 is a power and my 2/3 is a power. The last term I just copied. I didn't do anything with it. Okay. Now, when you look at this, notice that this is the log plus a log. So this looks like the product rule. So the product rule says that we're going to condense to a single log of a product. All right, so here's my single log and here's my product. Notice that the third term, once again, it just got copied. I didn't do anything with it. All right. Next, I notice that I have a log minus a log. Okay, well, this is going to be the quotient rule. So we will have the single log. And I'm noticing that I did something incorrect here. Let me uncover this as well. I went backwards instead of condensing. So you saw my mistake. Let me just delete that and let's fix it the way it's supposed to be. I'm supposed to be condensing. I accidentally went backwards and I was expanding. So that's my fault. So back to this, we have a log minus a log. So this is going to be log base A of a top, x to the 1/3, y to the 2/3, over the bottom, xy. So at this point, I have done what I was asked to do. I have a single log, but there's more cleanup that I can do. So remember that rule back from some of your pre-algebra, Algebra 1 days that said when you're dividing like bases, all you have to do is subtract the powers. And so I'm going to do 1/3 minus 1. And 1/3 minus 1 is negative 2/3. Okay, so I leave the base alone and I just subtract the powers. I can do that here as well. As long as bases are alike. There we go. As long as my bases are alike, I can subtract the powers. So keep the base, so that's going to be my y. 2/3 minus 1, or 2/3 minus 3/3 is negative 1/3. Okay. And there's a couple other things that I could do to this. For instance, I could rewrite this with roots. Okay. Right now, let's see what did the directions say. It said to assume all variables represent positive real numbers. Write the expression as a single log with a coefficient of 1. So this is going to be sufficient then. This right here is my single logarithm. So I have condensed completely. And I have simplified. There's a few other things that could be done, but not necessarily will it make it more simple. Okay? All right, and thank you for putting up with my mistake on that one. All right, one more little reflection question here before we go to example 7. Can the log base 3 of x plus 2, can it be written as the log of x plus the log of 2? And we would say no, it cannot. And the reason is because that rule has to be the log of a product. This is not the log of a product, it's the log of a sum. And we don't have a rule that says anything about that. Okay, so this right here would become log base 3 of x times 2, or 2x. Okay, now let's take a look at example 7. So we're told in the directions that the log base 10 of 7 is approximately equal to 0.8451. And so I'm supposed to find the next few things without using a calculator. All right, so if I could use a calculator, it would be fine, but this says I can't. So part A here says log base 10 of 49. Well, we know that 49 is the same thing as 7 squared. And all of a sudden, this is just my product rule. I'm sorry, not my product rule, my power rule. So I'm going to take my power out to the front and multiply. So this will be 2 times log base 7 of 10. Well, hey, leave the 2 alone. You're told in the directions that log base 7 of 10 is the same thing as 0.8451. So I'm going to just use substitution. I'll leave the 2 alone, but I'll substitute 0.8451 in for the log base 10 of 7. Now, this is something that I can multiply quite easily in my head. I don't need a calculator to just double this decimal. And so I did it in my head, and I got 1.6902. All right, let's try part B. So we've got log base 10 of 70. Well, let's see here. Log base 10 of 70. 70 is the same thing as 7 times 10, or 10 times 7, either way. So this is the log of a product. Let's use the product rule. So the product rule says we're going to break it up into log base 10 of 10 plus log base 10 of 7. So notice that the log of the product became the sum of my 2 logs. Well, log base 10 of 10, if you'll go back, if I can just direct you back to the properties, is going to look like this property right here. Log base 10 of 10, when those bases match, it's always going to equal 1. All right, so let's get back then to our question. Log base 10 of 10 is just going to be the number 1. Log base 10 of 7 was that decimal that was handed to us in our given set of directions. Add these two together, and you get 1.8451. Now, the last thing that this is going to touch on is just simply a theorem on inverses. And remember that the word inverse, we could say these are undo buttons of each other. They undo each other. 2 functions that are inverses are 2 functions that can undo each other. Once again, my A is positive, and it's not allowed to equal 1. So when we take a look at this, notice that it starts out looking like an exponential. This is a base A raised to some power, but my power is a logarithm. And so what you need to understand is that exponents and logs undo each other. They're inverses of each other. Since these guys have the same base, then the exponential and the logarithm undo each other. All that's going to be left is x. They undo each other. You know, it's kind of a lot like saying, hey, what's the square root of 1,295? Ooh, oh, squared. Oh, well, those undo each other, so I'm just going to be left with 1295. That's easy. And so this is very similar to that. The exponent and the log undo each other, leaving you with just the x. This one over here is the backwards version of that. Notice that I start out with a log that's raised to a power. And so again, that log and the exponential are undoing each other, leaving you with just an x. You could look at this as taking the x out to the front by the power rule. We were told in one of our properties just a little bit ago that log base a of a is equal to 1. And so x times 1 then is just x. So that definitely shows the backwards nature or the undue nature between exponentials and logarithms.